Assalamualaikum warahmatullahi and hi everyone. My name is Hakimie and now I will explain about the manometer. Alright, so first we got the YouTube manometer or the double column manometer. Manometer are pressure gauging devices using column of different liquids. We call meter fluid for fluid that determine the pressure, and the other fluid we call it the manometer fluid. The manometer fluid may be of higher density or lower density than that of the meter fluid. So pressures of liquid as well as gases can be gauged by using these devices. Manometers have connecting U-shaped tubes containing different fluids. So when one limb of the manometer is open to the atmosphere, it records the pressure of the source connected to the other limb. When both the limbs are connected to the pressure sources, the manometer records the differences of between the two pressure sources. Simple manometer and differential manometer are what this manometer called. The pressure of a liquid in a pipe may be measured by using a glass U-tube containing a heavier liquid which does not mix with the fluid in the pipe. Suppose the pipe contains water and mercury is used as the measuring liquid. Let the level EF correspond to the surface of contact of the two liquids, and let X be the center of the pipe. So in this figure, P is pressure intensity at X, Y1 is height of X above EF, Y2 is height of free mercury surface above EF. So pressure at E is the same as pressure at F. So we are expressing pressure in terms of water column. We got the equation as below. But in general, pressure head at X in terms to the column of liquid in the pipe, we got the equation Px over W equal to Sy2 minus Y1. S is specific gravity of the measuring fluid with respect to the fluid in the pipe. Right, so next up we got the inverted U-tube manometer. Sometimes a lighter liquid is used in a manometer. In such a case, an inverted manometer is used. In figure 2.39, pipes A and B contains liquid of specific gravity SA and SB respectively. A liquid of specific gravity S is contained in inverted manometer. Large deflection of the manometer liquid will occur even for small differences of pressure between A and B in such arrangement. Hence, contained in inverted manometer. Large deflection of the manometer liquid will occur even for small differences of pressure between A and B in such arrangement. Hence, measurement can be made accurately. We let W is specific weight of water. So specific weight of liquid in A and B respectively SAW and SBW. So for the case shown in figure 2.39, pressure intensity at E is equal to pressure intensity at F. So and at the end we got the equation PA minus PB equal to W SA times ZA minus SB ZB plus SA minus SY. Or in term of the head of water, we got the equation is PA minus PB over W equal to SA ZA minus SB ZB plus SB SY. For the particular case when the pipes A and B contain water, for example when SA is equal to SB is equal to 1, and when the pipes are at the same level, for example ZA equal to ZB. So the equation we got the PA minus PB over W equal to 1 minus SY. So the next manometer we got the single column manometer. So the single column manometer as shown in this figure is a modified. So the single column manometer as shown in this figure, is a modified form of the ordinary YouTube manometer. This manometer also has two limbs, one of which is made very large in area compared with the other. The area of the large limb, also called the basin, may be made 100 times the area of the other limb. The manometer contains a heavy liquid like mercury. The pipe in which pressure is to be determined is connected to the large limb. Alright, so now we look at the figure 2.55. Alright, so any pressure change within the pipe may only produce a really chicken feed in level of the manometer liquid surface within the basin. The changing level may be neglected, hence the reading within the narrow tube only is to be taken. Since there is no God to take any reading like the liquid surface within the basin, it needn't be made transparent. Usually it is made of iron. The other limb, for example the narrow tube, may be vertical or inclined to make it more sensitive. So let Xs to be extent of manometer liquid within the basin, and therefore the narrow tube when the manometer is connected to the pipe. Let after connecting the pipe to the manometer, the drop by manometer liquid level within the basin be delta H1. Let H2 is equal to rise manometer liquid level in the narrow limb. H1 is height of center of pipe above XX. Capital A is for cross-sectional area of the basin. Letter A for cross-sectional area of the narrow limb, and S is for specific gravity of the liquid in the pipe. SM is for specific gravity of the liquid in the manometer, and X prime is for specific gravity to the liquid in the manometer relatively to the liquid in the pipe. So this is what all the equations looks like at the end. Alright, so next example we got the inclined tube manometer. This is an improvement over the single column manometer. In this case, the manometer tube is made inclined in order to make it more sensitive. In this case, the displacement of heavy liquid in the narrow tube is relatively greater, and hence readings can be taken more accurately. Alright, so now we look at the figure 2.56. Alright, so we let theta be the inclination of the tube with the horizontal in order to overcome the effect of the surface tension. Theta shall not be less than 4 degrees. Let L is equal to length of the liquid column in the tube above the level of the heavy liquid surface in the basin. H2 is equal to height of liquid surface in the tube above the level of the heavy liquid surface in the basin. So H2 is equal to L sin theta. Pressure heading the pipe at A, as in the previous case, is the equation is like P A over W equal to S prime H2 minus H1 is equal to S prime L sin theta minus H1, where S prime is equal to specific gravity of the heavy liquid over specific gravity of the liquid in the pipe. There are a lot use of manometer in real life. For simplicity and accuracy, nothing beats pressure manometer. Many requirements for measuring pressure in industry, for example, to measure the fluid level, temperature, flow rate or hydraulic system pressure. For the measurement of low pressure, one such device is called pressure manometer. So this is the two example of application of manometer in real life, in real world. So first we got the measuring airflow. To measure the airflow is often used by a pressure manometer. Moving air creates a force that is proportional to velocity. This force, typically just a few inches of water column, is applied to the manometer for measurement and then converted to flow by a simple calculation. The measurement of flow in air in ducts or ventilation system is one such use of the manometer. So next we got the medical application. So in medical column is applied to the manometer for measurement and then converted to flow by a simple calculation. The measurement of flow in air in ducts or ventilation system is one such use of the manometer. So next we got the medical application. So in medical term, we use the manometer to measure blood pressure using an air cuff. Low pressure manometer may also be used to measure the
Assalamualaikum. My name is Mohamad Irfan bin Amin. My matrix number is AD190012. Today I would like to tell you more about barometer. First of all, a barometer is a scientific instrument used to measure atmospheric pressure. Also, it's called barometric pressure. The atmosphere is the layers of air wrapped around the Earth. That air has a weight and presses against everything it touches as gravity pulls it to Earth. Barometer measure this pressure. Atmospheric pressure was first calculated by a scientist, which is the name is Evangelista Torricelli. Evangelista Torricelli is also invented this barometer to measure the atmospheric pressure and also the change of weather. The first barometer device is invented in Florence, Italy in 1644. His invention has many modern uses, but barometers are especially important for weather monitoring and prediction. Oncoming storms cause fast drops in air pressure, so barometer readings provide essential warning for ships at the sea. There is the types of barometers. First, mercury barometer. Second, aneroid barometers. Third, digital barometers. This figure shows a simple mercury barometer which consists of 1 meter long glass tube closed at one and completely filled with mercury and kept inverted in bowl of mercury. A small quantity of mercury will drop into the bowl and thus form a vacuum at the upper end of the tube. The pressure acting on the surface of mercury outside the tube is atmospheric pressure. After a few seconds, the long glass tube invertedly filled into the bowl of mercury. There will be present of a space which is called Torricellian vacuum. The space above the mercury in the tube, which is called Torricellian vacuum, is not air bubble present, but it is vapors of mercury. Then we measure the height, which is the content height of mercury is 76 centimeter, and we convert into the meter, which is 0.76.
Then, to find the atmospheric pressure, we use the formula rho Hg, which is density of mercury multiplied by height of mercury multiplied by gravity. So, we will get 13,600 kilogram per meter cube times by 0.76 meter times by 9.8 meter per second square. So we get the atmospheric pressure, which is 101325 Pascal.
Then, this is an example of household barometer. This instrument is conveniently used as a household barometer. This device consists of a glass tube bent at the lower part to form a U-tube. The open end of the U-tube is enlarged. This enlarged part takes the place of the bowl or reservoir of the ordinary barometer. An iron block small weight is supported on the mercury surface partly by upthrust of mercury on it and partly by a counterweight. The iron block and the counterweight are connected by string taken over a pulley. Variation of atmospheric pressure brings about rise and fall of the mercury surface in the open end of the U-tube, which in turn causes the pulley to rotate by some angle. A pointer attached to the pulley will move over a circular scale from which the atmospheric pressure may be read.
Hello and Assalamualaikum. My name is Mohamad Zharfan Danial bin Ahmad Nazri with metric number AD190086, and in this video I'm gonna talk about the difference between the devices, which is the difference between manometer and also barometer. Thank you. Okay, difference between barometer and manometer. So as we can see in the slide, the first one is the shape. So there are two barometer. The first one is analog barometer, and the second one is 14 barometer. This is an example of barometer. So as a submission of manometer, barometer comes in one basic design, which is a closed-ended tube. Specifically, a traditional barometer is a glass tube with one open end and a vacuum at the other end. On the open end, atmospheric gas. Closed-ended barometers can be either U-shaped or well-shaped. In a well-shaped barometer, the tube of mercury stands upside down or inverted in a larger well of mercury, so that the closed-ended with the vacuum is the tallest point and the open end is suspended in the liquid. Outside gases then press down on the well of mercury, which expands into the closed tube. Moving on with the shape of manometer, so we can see that there are U-tube manometer in the slide, and both of them is a U-tube manometer. Only the difference is that the company, which is the Honeywell U-tube manometer. So manometer can be open-ended, closed-ended, or digital. An open-ended manometer is filled with a liquid like water or mercury, and the tube is U-shaped. Both tops of the U-shaped tube can be uncovered so that the atmospheric gases apply pressure to each side. In addition to the simple U-shaped open-ended manometer, many manometers have a bulb or some other attachment on one end that is filled with a high-pressure gas. This gas puts pressure on its end of the tube, while atmospheric gases do the same on the other end. Moving on with the inner liquid. So, barometers are usually filled with mercury. A heavy liquid is needed, or the barometer must be extremely tall in order to show the relatively large changes in atmospheric pressure. In a digital or analog barometer, there is no liquid, which is there are instead cells of air. While for manometers, like also barometers, glass manometers are generally filled with mercury or another heavy liquid. However, open-ended manometers can also be filled with lighter liquids that can show smaller changes in pressure. These liquids include water, oil, bromides, and benzenes. Using water or oil can fix the concerns with mercury, such as poisoning and toxicity. Next is how to calculate the pressure. Reading a mercury barometer is relatively straightforward because the open end is the only side affecting the mercury height. A user simply needs to read the mark height on the closed vacuum end. This should give the atmospheric pressure in millimeters or inches, which can be converted to torr. While for manometer, atmospheric pressure in an open-ended manometer is read based on the difference in height between the liquids in each arm of the tube, or on an open-ended manometer with atmospheric gas on both sides, the height difference is calculated in either millimeters or inches, which can be converted to hectopascal. Next, we have the difference, which is the purpose of the barometers and manometers. So, the barometer is a closed-ended vacuum, which is especially good for measuring atmospheric pressure. This has made the mercury barometer the traditional instrument for weather forecasting and meteorology field that depends on changes in atmospheric pressure to predict weather patterns. While for manometer, other types of manometer besides barometer can be used to measure pressure both lower and higher than the atmospheric pressure. By attaching a bulb or other device of high pressure gas to a manometer, the pressure of that gas can be calculated Alright, we have reached the pros and cons of both devices. So, we move on to the barometer pros. So, a mercury barometer is precise and offers a simple method of measuring the atmospheric pressure. It has low vapor pressure. And does not evaporate easily. It is inexpensive as it does not require any expensive equipment to be made. Lastly, mercury barometer offers flexible construction and requires low power for its operation. While for its cons, it can be overwhelming to handle and carry due to its bulky and large size and liquid mercury content. Also, not to forget, the glass tube can break easily if not properly handled. With a mercury barometer, taking the readings can be hard under certain hard conditions. Next, for manometer, the pros is actually it is suitable for low pressure application. It has low cost and it is simple in construction. A manometer does not have to be calibrated against any standard. The pressure difference can be calculated from the first principle. Also, it has better sensitivity. The manometer is available for a large range of filling fluids of varying specific gravity. Lastly, it has a good accuracy. While for its cons, manometers in manometers, the error are in manometers, the errors are introduced due to condensation. It is large in size and bulky. Next, it has no overrange protection. Leveling is needed. Other than that, it has slow response, which makes it unsuitable for measuring fluctuating pressure. No fixed reference is available. It has lack of portability. And so, from the price, the majority of barometer cost between $10 for basic digital model to $50 for large dial type barometer. For manometer, the price start from $101. From the price range, we can conclude that manometer is most expensive and the most cheap is barometer. With that, I end my slide and thank you.
In conclusion, manometers and barometers both measure atmospheric pressure, and manometers can measure more precise pressures of other gases. All barometers are manometers, but not all manometers are barometers. Barometers have one open end and a closed end with a vacuum. Manometers can be open on both ends or closed on one end. Manometers may have a high pressure gas attached to one end to be measured. It can be concluded that pressure measurement using manometers is a very widely used technique as gives us more accurate results. In function, the only type of pressure that can be measured with barometer is air pressure at any locality with reference to sea level, but the manometers can measure all pressures including gauge pressures. However, both barometers and manometers are now come in digital forms.